Hey guys, just want to do a real quick tutorial on how to use IDV. For those of you who are in Advanced Synoptic for MSU, this will most likely follow what your first lab is going to be like, so it should be helpful for you. So the first thing that we're going to do here is that we're going to want to change the background since we want to make it a little bit more printer friendly for this. So what you're going to do is you're going to go to View right here, and you're going to go to Color. Just change it to black on white. And now go ahead and change this for us. One of the other useful things as well is that, as you can tell, we don't have any of the states overlaid. So to get all that, just go to your dashboard. We're going to go ahead and unclick the world coastlines and do North America and Central America as well. And what it's going to do, it's going to go ahead and put it in blue. So we can change that since we're probably going to use blue later on for some of the things that we're going to be plotting on this. One of the best things to do is change it a little bit more towards a gray. Won't be using a whole lot of grays, but that way if we do decide to use black, it won't really clash with everything that's behind it. As you can tell, now it's a little bit more of what we're used to seeing. So the first thing we're going to do is that we're going to go ahead and plot sea level pressure. The first thing though is that we need our data. So what you're going to do is you're going to go to your data chooser, the we're going to go to the catalogs actually, Unidata, model data, and then you're going to go ahead and pick which one you want here. Now keep in mind the computers in the lab are fairly slow. Who knows when they'll ever fix that. So all these run a little bit differently, especially if you use a higher resolution model. It's going to take forever to load, essentially. So a lot of times I've just been using the NAM, and I've been using the 80 kilometer, so much lower resolution. We're just going to go ahead and grab the current data source. So we go down here and say Add Source. Wait for it to load up. It still takes a little bit of time. Alright, and so as you know here now in the field selector, which is what I tried to choose earlier, we have our 2D and our 3D parameters. So in here you have a whole mess of stuff that we can plot. The first thing that we're going to do is we want sea level pressure, so pressure reduced to mean sea level. It gives us times that we can run by default, or we can actually go to use selected, so we can pick selected time periods. Yeah, let's go ahead and we're just going to run one time period, make it a little bit better. And there's really no other tool inside of here that we're going to be using yet. However, we can do a contoured plane view, and I'll show you what some of this other stuff later means. I'm just going to do contour for now. Just go ahead and hit create display. A little glitch there for a second. That was always fun. The only thing I did to zoom in there is I just kind of spun the mouse wheel. So there we go. We have mean sea level pressure already on there. We can go ahead and right click on this little color table too as well and edit some things. Since I really want it all rainbowy, which how they plotted on there, I'm going to go ahead and select edit the color table. So again, just all you do is just right click on that part, hit edit color table. It's going to show us a whole bunch of options here that we can use. We'll show you a lot of this stuff later on. Go ahead and drag that over to a darker color. Grab your left clicker and just kind of drag it on over. Hit apply and OK. So then there we go. Now we have sea level pressure plotted on there. We're also going to want to do 500 as well. So we just go, again, we go back to our dashboard, click Field Selector. This one's in a little slightly different location. This is actually going to be under your 3D grid. It's going to be under Derived. So we're looking for a geopotential height at isobaric. So let's see if we can find that. They're always sometimes a little bit interesting to find, and I wouldn't be surprised if I've already clicked on it and missed it. Oh, because it's not under, I'm sorry, it's not under Derived at all. It's under geopotential height at isobaric. Okay, so the same thing, we already have the time overlaid. However, we are going to have to select a level. So on this particular example, we want the 500 millibars. So right there, contour plane view, we can go ahead and just keep that. So create display. Go back to our map. Same thing. You can just go ahead and click off this check mark if you want the sea level pressure to go away. And we're going to go ahead and change this one as well. You can really change it to whatever color you want. I generally keep them mostly the same, although I think your teacher prefers that you don't, even though she never really said anything to me. So we're just going to go ahead and keep doing that. Alright, so now we can actually overlay them. And that is the nice part about actually having them in separate colors. You can probably see them a little bit better than I have them done right here, but I'm not turning in this project, you are. Alright, so let's go ahead and click that one off. So next thing we got here, we have 850 temperatures. We also have to draw the fronts, which I'll show you how to do that as well. Alright, so same thing, go to Field Selector. For this one, it's going to be a little bit different. Actually, it's really not going to be all that much different. Temperature at isobaric. Now, the part where this one's going to be different is that, again, we're going to go ahead and plot this at 850. That's going to be slightly different. Time stays the same, generally. Color filled. This will show it a little bit more to how we're used to doing this. So go ahead and create display. Now, it pulls us up to this screen right here. So again, normally we just go ahead and click on over to the map. I'm going to want to do this first. 5 Celsius ain't too bad. It's a little bit easier to see at about 2. Distinguishing where your fronts are at. A little bit better if the gradients are a little bit tighter. 5 isn't too bad. You probably just keep it there if you'd like. I don't. So with this one, we now have our temperatures at 850. I believe it's the drawing tool. Is it the drawing tool? It is the drawing tool. So when you want to go ahead and start drawing your fronts and such, just go up here, click your drawing tool, and if you notice you actually have a low pressure cell, you have all the fronts, you can just kind of draw all that on, and makes everything a lot nicer. And it actually shows up on the side here. See right there, drawing control, as soon as you're done. I'm not going to draw. I really don't want to show my awesome ability. So that just shows that one for you. Next we have the find the thermal wind, 2 separate ways. So let's go ahead and get rid of the temperature. Same thing, going back to our dashboard. And I apologize. This video is probably very boring by now. So the first thing we're going to do is we are going to do it with vector subtraction. So we're going to need the flow vectors. Those are going to be in our 3D, and that's actually will be under derive this time. How I told you last time, the other part was and it wasn't. And see right there, flow vectors from the U and the V components. We're going to go ahead and keep them as the vector plane view. We want to go ahead and keep that same thing. First one, so we're going to need 2 levels for this one to be able to do vector subtraction to find the thermal wind. So the first one, we're going to have 100 hectopascals, or 100 hectopascals. We're going to do it at 1,000 hectopascals. And the second one, we can just go and jump right back over. It's already on that, so we're going to go ahead and click the 500 hectopascals, which puts it there. Alright, so with these, if you notice, they're very hard to tell what's going on. So essentially what we can do is we can just click this part. It's going to take us straight back to our dashboard, which is this is where we want to be. We want to change these a little bit. Let's go ahead and change this to 3. Now when you put 3 in there, you have to hit enter. It will not accept it unless you take enter. Let's make the spacing a little bit better too. I'm going to put this one at 2. You have to hit enter again. And if you'd like to change the color, you're more than welcome to. I personally do. So this is our 500 millibar winds and they will be showing up in blue. Alright, so they're right there. See how they're a lot nicer to see. Let's take our 1,000 millibar. Same thing. Make sure they're same size. Now the only part that's really important on here, you can change it to whatever size you like. The spacing has to be 2. Consistently on both of them, otherwise they don't really seem to line up very well, which is a problem, especially when you're trying to do vector subtraction. Let's change this color to red. That's pretty much how I've been doing mine all semester. And if you go back to it, if you notice, they're lined up end to end. So now you can start doing your vector subtractions for these. I'll go ahead and click those off. Next part is we're going to plot thickness. And if this is going a little bit too fast for you, just pause, get as far as you need to, and then, yeah. Alright, so thickness. This one, there's 2 different thicknesses that are used. So we're going to go under the 2D grid. We're going under derived. So if you notice, we have thickness, or 1,000 to 500 hectopascal thickness. That's the one we want, from what we know that thickness is. So the time is already taken. We don't really need to do anything else here. So let's go ahead and plot it. Now this one's pretty fun. Same thing, it always seems to use this type of color combination, which is fine. I normally like to change thickness a little bit for the color. So same thing, all I did was just left click onto thickness, pulls us up back over to our dashboard, or I could have just clicked onto my dashboard. We're going to edit the color table, and let's go ahead and change this to the 54 line. So generally you just kind of have to already click somewhere because it's already set up on this color. So we're going to do blue, and what we can do is that we can find the 5400 line, or as close as you can get to it. That's good enough for me. Blue. And then I'm going to go ahead and click over here because it's going to change a random color, unfortunately, as soon as I click on a new color. Same thing, just get to as close as I can. Turn that part red. Just kind of symbolizing like warm and cooler colors. And then it'll actually tell us mostly where that 5400 line is. We're going to have to change a couple things to get it to stand out a little bit more. So what we're going to do is go ahead and right click on that part, change range. Oh no, that's not what I want. Left click on that part, and we should take us right over to the dashboard and get rid of that part. Change interval, that's what I would like to do. So let's go ahead and change that to 50, see what happens for the contour intervals, a lot like we did for temperature. This should give us a little bit more of what we want. See, yep, there we go. 5400 line. And you can actually, if you want to get real meticulous about it, you can change the color of that line. I'll let you go ahead and figure out how to do that. It's just manipulating some of the color schemes. But this video is already starting to get rather lengthy, so let's move on. The last part is going to, we're going to want to plot the jet at 300 millibars. So same thing, go into our dashboard. And where's this one located at? It's 3D, that's right, it's under 3D, derived, and speed from the U and the V components. So all we got to do is just go over to the level, and select 300. And this is kind of cool. This is a nice little neat trick that I learned from one of the other classmates. We're going to go ahead and do color contour, or color filled plain view first. So it's going to go ahead and plot this on here. Now, problem is we lost our map underneath. So just go ahead and left click onto that part. If you notice down here, position, just drag that all the way to the top. Take a second to load, and look, alright, there we go. Now we have it. There's a couple problems with this as it stands right now. First of all, we're in meters per second. So we need to change that. So we're going to go ahead, go up to Edit, change Display Unit, go to knots, something a little bit more what we're used to seeing. And we're going to change the interval just to a nice even number. And I should have changed the max value while I was there. Apply. That might not have changed. If I remember correctly, that doesn't change it. Nope. So see, to actually change this number, you have to go here, you have to right click, change range. I don't know why it does this. It's dumb. You don't think it should do it like that, but it does. So now we change the range on here, and it looks a little bit nicer. Just, something a little bit more what we're used to seeing. Now here's the cool little trick that you can do with this. As long as you plot the color filled part first, we can actually go back onto our field selector. Everything is already plotted exactly like we want. So let's just do the contour view. Create display again. Now we're going to have to change this one just like we changed the last one. So that's not what I wanted. That's right, it's change display unit. See, I still forget constantly. I have to play around with this to remember what I'm doing. Change the intervals. Just because I changed this one last time, we'll change it again. Now we'll go back to here. Right click, change range. And also, if you want to remove some of these other features on here that you want to see, you just want to see the jet, you can actually increase this value, and that'll take care of that. Alright, and just to get this to pop out a little bit more, let's go to Edit Color Table. If I can drag that little circle down here, there we go. Set that up. Apply, and now we actually have values associated with this. You don't have to sit here and try to make a legend to do all that. So this is pretty much a real quick example. There's a lot more things you can do with this program. It's very, very nice. I highly encourage you to play around with it. If I selected more times, we could have put this thing into motion, really see what was occurring through all of it. You can also overlay several features as well. Just keep in mind that some of these color-filled ones, if things aren't at the same level, it blocks stuff out. So you can try to do what we did with the maps to bring stuff forward, but that doesn't always work, which again is kind of a pain. So you just got to play around with it, see what all you can do, click on some of these features, and yeah, enjoy. Alright guys, thanks for